We're going to review phase changes. This is something that you probably learned about in high school. You may have also learned about it in middle school. So let's start with three phases of matter. We're going to restrict ourselves to Earth for this discussion, so we just have three phases of matter. Gases are on the left. This is an image from your book, and you can see that for gas particles, the particles are all pretty distant from each other. They move around pretty quickly. They don't really sense the presence of other gases. They don't feel each other's presence. They rarely collide. And gases you would have learned a lot more about last semester when you learned about the gas laws. This particular chapter, we're going to go a little bit further into the other two phases of matter, liquids and solids. Liquids are shown in the middle, and you can see that liquids, in this case, the particles do interact with each other. They come close to each other, but they're not static, really. They can move past one another very easily. And the one on the right are solids, of course, and solids and liquids are both considered condensed phases as opposed to gases, which are not condensed. The solids, the particles are very close together, and they're held in a relatively ordered arrangement. We're going to look at different types of solids a little bit. Okay, a little bit more about phase changes. Here we have our three phases of matter, solid on the left, liquid in the middle, and gas on the right. First, we're going to convert the solid to the liquid. That's called melting or fusion. Converting the liquid to the gas is called evaporation or vaporization. If we go in the reverse direction, we can convert the gas to the liquid in a process called condensation, and then further convert the liquid into the solid in a process called freezing. Most of that is review. We can also go straight from the solid to the gas phase in a process called sublimation. And the hardest one to remember is the opposite, gas to the solid, is called deposition. We're going to look a little bit at the thermodynamics of phase changes. First, I want to call your attention to this arrow on the left is enthalpy, which is, remember, abbreviated with a capital H. Enthalpy is increasing from the solid to the liquid to the gas, and so the solid has low enthalpy, and the gas phase has high enthalpy. If we look at conversions, those phase changes that we talked about, going from a solid to the liquid or melting, aka fusion, that is an endothermic process, which means heat must be absorbed. That means that delta H of fusion is positive. And then if we convert the liquid into the gas, because we're still moving up in enthalpy, that is also endothermic, and that heat of vaporization is what we call it, that is also positive. Now we can add those two together, and that gives us the heat of sublimation. Sublimation is also endothermic, so it has a positive delta H. And not only is it positive, but you learned last year, because of Hess's law, that the heat of sublimation is simply the sum of the heats of vaporization and the heats of fusion. And that's because enthalpy is a state function. All that matters is the initial state and the final state. So this heat of sublimation is equal to the heat of vaporization plus the heat of fusion because of Hess's law. Now if we go in the reverse direction and we convert the gas into the liquid, then we also learned last semester that because this is the reverse of vaporization, that it is not only exothermic with a negative delta H, but it is the opposite sign but same magnitude as the heat of vaporization. So let's say the heat of vaporization for something is 40 kilojoules per mole. That means that the heat of, I guess it would be called the heat of condensation, we don't usually use that word, but the heat of condensation, if heat of vaporization is 40 kilojoules per mole, the heat of condensation would be negative 40 kilojoules per mole. It would release the same amount of heat. And then, of course, the heat of freezing, again, we don't really call it that, but it would also be exothermic with a negative delta H, and it would be equal in magnitude and opposite in sign of the heat of fusion. Now we're going to erase all this stuff about enthalpy, because I also want to talk about entropy, which is also in this figure. Entropy is the arrow on the right-hand side, and you can see, remember, entropy is abbreviated with a capital S, and the solid phase has low entropy because remember that those particles are well ordered, and the gas phase has high entropy because those particles move around randomly, converting the solid into a liquid. Because we're going from low entropy to moderate entropy, has a positive sign for delta S. Entropy is increasing. That's also true going from the liquid to the gas phase. Delta S is positive. And of course, it's also positive if we go from the solid to the gas. And this delta S is also the sum of the delta S of fusion and the delta S of vaporization. Hess's law also applies to entropy because it is also a state function. Now going in the opposite direction, going from a gas to a solid, we are losing entropy. Entropy is falling, which means delta S is negative, which would be sort of an unfavorable process. Right? High entropy is good, low entropy is bad. So negative delta S is unfavorable. So now that we've looked at phase changes more in detail and looked at the thermodynamics of phase changes, this is just a little bit more of the image from your book. A reminder that converting a solid to a liquid is called fusion or melting, and that going in the reverse direction is called freezing. All of the phase changes that go up, so from the solid to the liquid or from the liquid to the gas or from the solid to the gas, those are all endothermic, and so delta H is positive. And then the reverse process going down, all of those processes are exothermic. As you can see, the delta H signs are given there for fusion and freezing. The change in sign for entropy is also positive as you go up and also negative as you go down. Going from a liquid to a gas is called vaporization. That is also endothermic. And condensation, the reverse process, is exothermic. And then, of course, sublimation is going from a solid to the gas phase, and deposition is the reverse process, going from the gas to the solid phase. This is review. The last thing is just a reminder before we talk about heating curves and cooling curves that we can convert ice into the liquid by heating it or adding heat. And if we continue to heat this sample, it will boil and convert into the vapor phase. We could, however, go in the reverse order, and we could cool the heated liquid down to room temperature and then cool it further to the solid phase. It's a reminder that we can either add heat or we can remove heat.